Welcome to our 10th short video segment from the chapter Tools of the Trade from our AP Chemistry notes at Allen High School. We were at the point where we were discussing ways to determine the molar mass of a substance experimentally. Anymore, we would use much more complicated equipment from this than doing the ideal gas law or colligative properties, but I still think that they're valuable learning opportunities and great for critical thinking skills. So let's take a look at those and refresh our memory. We again saw them in pre-AP, but we do need to refresh our memory on these. Now, hopefully you remember simple PVNERT, P, pressure, volume is equal moles times the ideal gas law times the temperature, and we called that PVNERT. And I'll talk about units again in just a moment, but let's look at the variations that we have. This formula is given on the AP formula chart. This one, all we've done is popped in that quick substitution that moles are equal to mass over molar mass. It's not given on the chart that the substitution is, as is this formula, but this particular format is not provided. Now this last one is going to give us an indication of why I have little stinky cat here. And it's simply rearranging. What we're doing is we're solving this for mass over volume, which is our density. So that gives us a density term in here. So that D stands for density. And if we then rearrange that for molar mass, we get what I call the meow meow. Now, not everybody uses mm for molar mass. I like to do that to distinguish it from molarity. So we call in our class molar mass. Mm is meow meow because cats put dirt, DRT, over their pee. So it's not given on your formula chart, but if you remember the meow meow equation, it's a simple way to remember that formula. Now, when we talk about units, we've got to be very careful with this. Volume has to be in liters, and that's because all of our forms of R, this is a little bit hidden, but it's really in there as well, have liters in them. So volume must be in liters. Temperature, of course, must be in Kelvin. It's not a change in temperature, it's a pure temperature. And Kelvin is our physically meaningful temperature unit. N is moles. That's nothing else possible for that. Now, what we do for pressure is we match the units of R. So you have a choice. Use simply one form of the R, or convert your pressure units, or memorize different values for R. So if pressure's in atmosphere, R has to be 0.0821. If pressure's in torr, R has to be 62.4, and if pressure's in kilopascals, R is 8.314. Now, R is kind of like pi. It just seems to show up at very random places. Now, the first one you want to always look at is match your pressure units when possible. Okay? If you have an energy term in the equation where R has popped up, whenever there's an energy term, you have to use 8.314 because that's the one that has joules in it, and joules is a unit of energy. And then finally, if we can't match P, there's no energy term, the default is typically for most formulas going to be atmospheres. So that's how I would approach those units. And now it pretty much boils down to plugging into formulas. So I tried to be a little cutesy here, and we've got a nice little cartoon taken from a website. Cows produce a significant amount of methane gas. I don't even want to consider how that's measured, honestly. I don't know if they use tubing, just saying. All right, so what do we have? We have volume. You can list your givens if you want. In AP, that takes a lot of time, so I tend to just circle and note what I have. So temperature is 21. We know right away that that has to be converted to 294.15 Kelvin. You know how to do that. Remember, you add 273. 0.15. Typically, I'll include the 0.15 if my given goes to the tenths place or more. We have our volume, and the units are okay, so I can keep that as volumes. And I have a pressure. And since my pressure is in kilopascals, I want to make sure I use the R that corresponds to kilopascals. Now, If I were queen of the world, we would always use kilopascals because that's getting us closer to our SI units. So we're going to use R equal to 8.314 in this case. Now, since it says how many moles, I know that I'm using my simplest of PV-NERDs. PV is moles times R times T. I'm going to solve that little literal equation for moles are equal to pressure times volume over gas constant times temperature. Okay? And so that means my moles are going to be, just plug in at this point, 202 times my volume, which is 32, over 8.314. Sorry, it's getting a little messy down on the bottom here. 294.15. Now, when I do this mathematics, my moles are equal to 2.643. Now, a word about significant figures here. Notice that the volume has two significant figures, and that's 32 liters. R we consider a constant. The pressure has, sorry about that bell, the pressure has three significant figures. Now the temperature actually has four significant figures because I can round to this place here, because this went to the tenths. When I round here, I go to the furthest decimal place to the left. We are still limited by the two sig figs in the volume. So if you want this to the correct sig figs, it would be 2.6 moles. And I am going to continue working on these in another video clip. So join me in a couple of minutes for our other, when you take your break, join us for the other little video clip using the ideal gas law or forms of the ideal gas law.